I'm Anil Kumar, sharing with you a question from my student Melissa, and I hope its solution is going to help many. First, let me thank her for sharing this question with me. It is on chain rule for finding derivatives. The question is, find first derivative of f of x equal to square root of x plus square root of x. You see, within the square root, we have another square root. So it's a composite function, right? Now, we can find derivative of such functions using chain rule. So let me explain you step by step. First, let me write this as y equals to f of x, as you know, is the y value, square root of x plus square root of x, and both are under square root like this. Finding derivative means we need to differentiate with respect to x, right? That is to find dy dx. So dy dx of the whole thing will be d dx of the whole thing, which is square root of x plus square root of x, both within the square root, right? Now you can treat this as the function inside to the power of half. So we'll apply the power rule on the outside, correct? So let me go one more step just to make it more clear. I know some students need this step also. So it's kind of like this, x plus square root x, and this square root really means to the power of half, correct? So if you apply the power rule, you get half times everything, which is half times x plus square root x to the power of half minus 1, correct? Now that is the derivative of the outside function. We are applying the chain rule. We have to multiply it by the derivative of inside function, correct? So times d dx of inside function, which is x plus square root x, correct? Which is x plus square root x. Do you get this step? So this is kind of critical step in finding derivative of the function, right? We call this as chain rule, right? So we call this as chain rule. Which really is that if I have a function f of x as combination of h of g of x, in that case the derivative of the function will be derivative of h of x times derivative of inside function. So this is that g of x. Do you see that? This part is g of x, correct? And this part is the derivative of outside function, right? You could also do it by substitution to make it very clear. Okay, so that's how we can do it. Now let's continue to simplify. So we have this as to the power of minus half, right? Let me write this as x plus square root x to the power of minus half, and then derivative of d dx of derivative of x is 1 plus this is x to the power of half, so we get 1 over 2 times x to the power of minus half, correct? Okay, so let's take it to the right side and then we'll try to simplify it. Okay, so let me change the ink also. So what we have got here is dy dx as equal to, so since this is to the power of minus half, everything comes in the denominator, right? So we could write this as 1 over 2 times square root of the whole function, which is x plus square root x, correct? Times, now this derivative is 1 plus, so there's also minus half, so square root function derivative is 1 over 2 square root x, correct? So that becomes the expression. You could take this term common, correct? So if you take 2 square root x common, then you get what? You get 1 over 2 square root of x plus square root x times, let me write this as 2 square root x, and here we get 2 square root x plus 1, or let me write down the final answer. Numerator we have 2 square root x plus 1, and in the denominator 2 times 2 is 4 times square root x times square root of x plus square root x. Is it okay? So that is the derivative of the given function. Now it's very important to understand how the chain rule has been applied, and then we have solved this particular question. Now for some of you, you could also do it by substitution, and I'll not solve it using substitution, but what you can do here is that you can substitute, let's say u equals to x plus square root x, and in that case we can write y equals to, right? It becomes easier to use this nomenclature, y equals to square root of u. Do you see that? And then you can find dy du and multiply it by du dx to get the same answer. So that could be an alternate approach, which is a very good approach to apply. So most of you could actually do this. That's straightforward and much simpler. I'm Anil Kumar, and I hope both these methods help you to understand how to find derivative of function of functions, which could be complicated at times. So if you get a complicated function, use substitution, right? I'm not saying this is not a complicated function, but it could be more complicated than this. I'm Anil Kumar, and I hope it helps. You can always share and subscribe to my videos, and if you like, I'll appreciate you to put some likes. Thank you, and all the best.